Genius Math and Physics. In this video, we will dictate some important questions related to 3 marks. The first question you can take from equivalence relation like this: AB related to CD showing equivalence relation. While you have to prove an equivalence relation, we must check whether the relation is reflexive, then symmetric and transitive. If all three holds good, then we can say it is an equivalence relation. In this video, we are getting AB related to CD, A plus D equal to B plus C. Its meaning is that A plus B, we can write it as B plus A. Therefore, we can write AB related to AB. Its relation meaning is that first plus fourth must be equal to second plus third. You see here, first plus fourth is equal to second plus third. First plus fourth equal to second plus third. Similarly, test of symmetric, you have proved it like this: A plus D, B plus C, C plus B, D plus A. Therefore, C related to AB. So it is symmetric. Similarly, if we take AB related to CD, then equation 1 rises like this: CD related to EF, then C plus F equal to D plus C. If these two holds good, then you have to prove that AB and EF must be in the same relation. So in order to prove this one, we can add equation 1 and equation 2. While adding equation 1 and 2, the D plus C will be cancelled from both sides. Therefore, A plus F equal to B plus C. So first plus fourth is equal to second plus third. First plus fourth is equal to second plus third. Therefore, relation is also transitive. Therefore, it is an equivalence relation. We can prove it also by AD is equal to BC or A by D is equal to B by C in the same way. Question is f of x equal to 1 minus x to the power 1 by 3. Then prove that f of x equal to x. In this question, you are given f of x is equal to 1 minus x to the power 1 by 3. We have to find out f of x. Its meaning is that f of x. Since f of x is equal to 1 minus x to the power 1 by 3, therefore f of x would be 1 minus f of x whole cube to the power 1 by 3 because of x stands for f of x now. So 1 minus, put the value of f of x, 1 minus x to the power 1 by 3, again to the power of 3. So 3 would be cancelled. So 1 minus x cube, that is only x cube, to the power 1 by 3 is equal to x. In order to get the 3 marks, the 3 marks question from the function, maybe from FOG of x and GOF of x. This we have to practice these two questions, taking two different functions. You have to prove FOG of x and GOF of x. Question number 3. Y is equal to ln 10 of pi by 4 plus x by 2, then prove that dy by dx is equal to sec x. This question also 3 marks question. So y is equal to ln of this one. We can take the first derivative, y1 is equal to ln 10 of this one. So ln is derivative 1 by 10 of pi by 4 plus x by 2. Now 10 pi by 4 plus x by 2, its derivative is x square pi by 4 plus x by 2. Again pi by 4 plus x by 2, its derivative is half. We applied chain rule here. So this becomes 1 by 10, it is cot. Cot means cos of pi by 4 plus x by 2 divided by sin of pi by 4 plus x by 2. Sec square 1 by cos square 1 by 2. Cos of pi by 4 plus x by 2, cos square pi by 4 plus x by 2, it will be 1 cos will be cut down from here. So answer becomes 1 upon 2 into sin of pi by 4 plus x by 2 into cos of pi by 4 plus x by 2. That is 1 by 2 into sin A into cos A, or by sin 2A. So this is sin 2A. So that is sin of 2 into pi by 4 plus x by 2. 2 into pi by 4 plus x by 2, it is pi by 2 plus x. Sin of pi by 2 plus x is cos x. 1 by cos x equal to sec x. 2y is equal to, next question, if 2y is equal to x into 1 plus dy by dx, then show that y2 is constant. In this question, we are getting 2y equal to x into 1 plus dy by dx. Dy by dx will be written as y1. Now if you differentiate both sides with respect to x, y will be differentiated first time, so it will be y1. X into 1 plus y1 will be differentiated by using product rule. First into derivative of second. First into derivative of second 1 plus y1. Its derivative is y2 because of y1 is 1 is known. 1 is constant, its derivative 0. Plus again 1 plus y1. Derivative of x is 1. you applied here product rule. First into derivative second, first into derivative second, plus second into derivative first. Now again differentiate with respect to x. So y1 will be differentiated, so you get y2. y2 will be differentiated, so that is y3. y1 is differentiated as y2. So this is product rule, x into y2, x into y3 plus y2 into derivative x. 1 plus y1 its derivative is y2, y1 is no derivative, 0. So xy3 becomes 0 after cancelling 2y2 from both sides, y3 0. If a function is 0, if a function's derivative is 0, no doubt the function is constant. Because of y2 is constant, so its derivative is. Next question number 5. Form a differential equation of y is equal to a sin inverse x plus b cosine inverse x. We are given y equal to a sin inverse x plus b cos inverse x. So its derivative is y1 is equal to a sin inverse x is derivative root over 1 by root over 1 minus x square minus b into 1 by root over 1 minus x square. Because of derivative of cos inverse x is minus 1 by root over 1 minus x square. Now root over 1 minus x square into y1 is equal to a minus b. If we square both sides, then I get 1 minus x square into y1 square is equal to a minus b whole square. But a minus b whole square is a constant quantity, so its derivative becomes 0. And its derivative will be 1 minus x square into y1 square is derivative 2y1 into y2. Here the chain rule is applied here. Plus y1 square into 1 minus x square is derivative minus 2x equal to 0. This expression is obtained after applying the product rule to the left hand side. Now this becomes 2y1 if we will take common. It is 1 minus x square into y2 minus xy1 equal to 0. Therefore 1 minus x square y2 minus xy1 equal to 0. Here no constant is there. The constants have been eliminated and the differential equation is obtained.